Are you ready to learn the truth about the most impressive transport network of the ancient world? What if I told you that thousands of kilometers of roads built 2,000 years ago still serve as the basis for modern European highways? The ancient Roman Empire, which ruled over a vast territory, managed to create a logistical masterpiece, a network of roads that allowed it to survive for over 1,000 years. Modern builders, faced with years of repairs on a single small section, can only envy the genius and efficiency of ancient engineers. Watch the video to the end to find out how Rome achieved such incredible construction speed and what made these roads almost eternal. What if I told you that everything you believe was wrong? It is important to understand that Roman roads were not just a means of getting from point A to point B as we perceive modern highways. For Rome, the road was primarily a strategic tool, a symbol of its power and a means of strengthening it. Every new mile laid through mountain passes or wild forests was a statement of territorial claims and the irreversibility of the Roman presence. The Romans thought of roads as the architects of their state. Road construction had a deep military and political philosophy. The faster the legions moved, the faster orders were delivered, the faster taxes were collected, and thus the stronger the power. A delay in the delivery of military reinforcements could cost an entire province, and the Romans did everything to prevent this. Speed was not a whim, but a matter of survival for the empire, and their logistical decisions were aimed precisely at minimizing time. The first great Roman road, the Appian Way, became a model for all subsequent roads, demonstrating that straightness and durability were more important than economy. It was laid out in as straight a line as possible, even if it meant cutting through hills or crossing swamps, which was fundamentally different from the winding local trails. It was an engineering and political manifesto affirming the superiority of Roman will over nature. The political significance of the road was no less important than its military significance. Provinces connected to Rome by solid roads were assimilated more quickly, their culture and economy integrated into the imperial system. The road carried Roman law, the Latin language, and Roman money, making the conquered lands part of a single organism. Military management, which we will discuss later, was only one aspect. Another aspect was the psychological impact. The sight of a perfectly flat, paved road leading into the unknown inspired awe in the conquered peoples and a sense of pride in the citizens. The road was tangible proof of Rome's power, which could not be denied. While other civilizations built great temples and palaces, Rome invested in infrastructure, understanding that the empire's longevity depended on its connectivity. Roads were the lifeblood of the state, carrying life, information, and power. This philosophy, which placed longevity and strategic importance above short-term savings, led to the creation of roads, many of which still exist today. The lesson was simple. Don't skimp on the foundation of your power, and it will be eternal. We are very interested in hearing your point of view. What do you think about this approach to road construction as a tool of political power? Write about it in the comments. And of course, don't forget to subscribe to our channel so you don't miss out on other historical investigations. Want to know the main secret that can change not only your perception of the ancient world, but also your approach to any large-scale undertaking? It is hidden in a word that seems boring at first glance: standardization. It was the foundation of Roman success. If we imagine that every modern construction company builds roads according to its own rules, we would end up with chaos, incompatibility, and endless maintenance problems. Rome took a different path and introduced a single, strict standard for all its roads, regardless of whether they were built in Gaul, Africa, or Asia Minor. This universal system made it possible to scale construction to volumes that were truly incredible for the ancient world. Roman engineers developed detailed regulations that precisely defined the number of layers of the roadbed, their thickness, the materials used, and the standard width of the roadway. As a rule, the road had a 4- or 5-layer structure where each layer performed its own function, from drainage to load distribution. This approach ensured the same strength and durability of roads throughout the empire. There was no need to invent new solutions for each new section. The technology had already been developed and tested over time. This system was based on strict repeatability. Any road built to Roman standards was predictable. Soldiers, merchants, and officials knew exactly what to expect in terms of surface, width, and quality. This greatly reduced risks and simplified planning for long-distance travel. The central element of navigation on these roads were the so-called miliaria, stone pillars erected along the routes at intervals of 1 Roman mile, which was approximately 1,180 meters. These pillars were much more than just distance markers. They were part of a unified navigation and logistics system that covered the entire empire. Each milestone was carved with the distance to the nearest major cities, and most importantly, to Rome itself. This allowed travelers, merchants, and above all, the military to accurately calculate routes, speed of movement, and travel time. Each such pillar served as a tangible reminder of the center of the world, to which all roads symbolically and literally led. In addition, the milestones served as a kind of information bulletin. They often bore the name of the emperor under whom the road was built or repaired. This had a powerful propaganda effect. Any traveler could see who was responsible for order, security, and infrastructure development. The road became a stone manifesto of state power. Thanks to standardization, any construction crew, whether a unit of legionnaires or hired workers, knew exactly what to do and how to do it. No lengthy training or adaptation to local conditions was required. Engineers could be confident in the quality of the work even when they were thousands of kilometers away from the construction site. This was the key factor that made it possible to build roads quickly, on a large scale, and with predictable results. A unified system of weights and measures, as well as standardized construction standards, allowed Rome to create the most extensive road network in the ancient world. At its peak, it exceeded 80,000 kilometers and connected Europe, North Africa, and the Middle East into a single space. Many modern transport corridors still follow the direction of these ancient highways. Clear standards reduced corruption and limited the possibility of shoddy work. Any road could be easily checked for compliance with established requirements. It was easier and safer to follow the instructions than to try to save money at the expense of quality and risk punishment. The Romans understood perfectly well that even the most ingenious engineering solution is useless if it cannot be reproduced on a mass scale. Standardization transformed road construction from a craft and an art into a technological process. This is what gave Rome a decisive advantage in speed, control, and space management. Miliaries were not just stone pillars on the side of the road. They were the pulse of the empire, the steady beat of its rhythm. Want to know what other unexpected solutions allowed Roman legions to move faster than modern cars on toll highways? You've definitely never heard about this unique secret. If you think that road construction in the Roman Empire was carried out exclusively by civilian slaves, hired workers, or contractors, you are seriously mistaken. The most powerful, disciplined, and effective construction unit in the empire was its own legion. The Roman army was not only an impeccable fighting machine, but also a colossal engineering organization, capable of changing the landscape to suit its needs in the shortest possible time. It was precisely this military approach to managing projects, resources, and people that allowed Rome to achieve phenomenal speed in road construction. The legion did not wait for someone to prepare the infrastructure at its destination in advance. It literally built the road as it advanced, paving the way for its own marches. Each legionnaire was not just a soldier with a sword and shield, but a universal specialist, an engineer, digger, surveyor, carpenter, and builder all rolled into one. In addition to weapons and armor, his backpack always contained tools for digging, leveling the ground, cutting wood, and clearing the area. Military management of construction projects was radically different from civilian management. It was characterized by strict discipline, the absence of any trade unions, protests, and conciliation procedures, as well as incredible speed in decision-making. The military tribune did not spend months discussing and approving estimates. He gave the order, and work began immediately. The road was part of a combat mission, and its construction was subject to strict military regulations and schedules. The Military Engineering Corps, often referred to as the Architects of the Legion, was responsible for the design, layout, and quality control of the route. These were highly skilled specialists trained in surveying, hydraulic engineering, and construction. They knew exactly how to maintain the required slope, how to drain swamps, reinforce the soil, lay a road through rock formations, and avoid dangerous areas. Their practical experience, accumulated over dozens of campaigns, was invaluable. The Legionnaires worked with remarkable efficiency. Thanks to constant training, iron discipline, and a clear hierarchy, they could instantly mobilize thousands of people to perform a single task. The division of labor was extremely clear. Some cut down trees and prepared wood, others dug trenches and leveled the ground, others brought in stone and gravel, and still others laid down layers of roadbed. It was a real conveyor system deployed right in the field. The military camps that the Legion set up every evening were not only fortified strongholds, but also full-fledged logistics and construction bases. They were used to carry out engineering work, store tools and materials, and distribute work crews. Stone, sand, and wood were often obtained locally from quarries and forests, or delivered by river and sea. Logistics was an integral part of military science and was carefully planned. For particularly complex structures, such as bridges, crossings, and aqueducts, specialized cohorts or experienced engineers could be called in. However, the main, most difficult, and voluminous work, excavating soil, laying foundations, and laying the base layers of the road, was performed by ordinary legionnaires. This was their daily duty, hard physical labor that was part of their routine. Thus, the Roman army was a completely self-sufficient construction force. It did not need to pay salaries in addition to maintenance. It did not need to enter into contracts or conduct negotiations. It only had to carry out orders. This explains the incredible speed. The same force could simultaneously fight, advance, and build infrastructure that immediately began to function. This approach, in which military effectiveness depended directly on the quality of roads and logistics, made road construction the #1 strategic priority. Missing deadlines or poor workmanship were seen as a failure of a combat mission, not just a construction mistake. This created powerful motivation and maintained the highest level of performance. Like this video if you think Roman legionnaires were not only great warriors, but also the most efficient builders in human history. Also, don't forget to subscribe to the channel so you don't miss any new videos. What you are about to learn will change your perception of ancient technologies. The Romans didn't just throw stones on the ground, they created entire engineering marvels that still amaze historians and architects today. Roads were built on the principle of a multi-layered cake, where each layer had its own purpose and was designed to last for centuries. Even in the harshest natural conditions, on mountain passes or in damp lowlands, these roads remained strong and were not washed away by rain and snow. The secret of their durability lay in careful calculation, craftsmanship, and the use of materials that ensured the stability of the structure for centuries. Each layer of the road had its own logic and purpose. From drainage to load absorption, it all started with laying the foundation, which was called the fundamentum. First, engineers leveled the ground, removed excess stones and vegetation, and then dug a deep trench up to a meter, sometimes 1.5 meters. Large stones were laid in this trench, carefully fastened with a mixture of lime and sand. This bottom layer served as drainage, diverting water and preventing the entire road from subsiding. Without it, none of the upper layers could maintain their shape, and the road would quickly collapse under the rain and meltwater. At this stage, the foundations of strength were laid, on which the durability of the entire structure depended. Above the foundation was the second layer, the statumen. It was made from a mixture of crushed stone and gravel bound with lime mortar. This layer was denser and served as the main load-bearing structure, evenly distributing the load from the wheels of carts and the movement of people. It served as a kind of road frame, protecting the lower drainage layer from deformation. Thanks to the statumen, the road could withstand heavy weights and retain its shape even under heavy use. Roman engineers understood that the strength of the structure depended not only on the quality of the stones, but also on the accuracy of the laying and the thickness of the layer. The next layer, the ruthless, consisted of smaller gravel, broken bricks, ceramics, and clay, sometimes mixed with lime. It ensured the surface was level and prepared the road for the top layer to be laid. The rudis also served as a shock absorber, softening the impact of cartwheels and preventing cracks in the top layer. This layer was especially important because it supported the entire structure of the road. Thanks to the rudis, the top layer could last for decades without losing its shape or functionality. Finally, the top layer, the crusta, consisted of perfectly fitted flat stone slabs. These slabs of hard basalt or other stone were laid so tightly that it was almost impossible to insert a knife blade between them. This covering provided a perfectly flat surface for the movement of wheels, carts, and pedestrians. In addition, the tightly laid stones did not allow water to seep into the lower layers, protecting the rudis and statumen from destruction. The top layer was a true masterpiece of engineering, combining practicality and durability. Massive stone curbs were always installed along the edges of the road. They fixed the roadbed in place, preventing the materials from spreading and collapsing under load. The roads had a slight slope from the center to the edges, allowing water to drain into side ditches. This rainwater drainage system was vital to maintaining the strength and evenness of the pavement. Even during heavy rains, the road remained passable, and the water did not destroy the layers beneath the pavement. It was a simple but ingenious engineering idea. The entire system was designed for one main purpose: to protect the road from moisture. Water, especially during rainy seasons, is the main enemy of road surfaces. The Romans learned to solve this problem with well-designed drainage and a dense top layer. Thanks to this, the roads could serve for decades, withstanding loads, temperature changes, and the constant movement of people and animals. Each road was a true engineering masterpiece, thought out down to the smallest detail. This standardized construction technology was the secret that ensured Roman roads would serve for thousands of years. Each road was, in essence, a stone bridge built not for years, but for centuries. Roman engineers took into account all possible loads, weather conditions, and wear and tear when creating networks that connected cities, provinces, and colonies. These roads became the basis for Roman expansion and trade, ensuring the rapid and safe movement of troops and goods. What if I told you that one of the tools of warfare was water? Unlike ancient trails which wound around every hill and stream, Roman roads were remarkably straight. The famous square mile principle and the use of sophisticated surveying instruments allowed the Romans to lay out routes with minimal deviations, which directly affected the speed of movement and, as a result, the speed of construction. To achieve such accuracy, Roman engineers used a unique tool called a groma. It was a simple but ingenious surveying device consisting of a cross with plumb lines attached to a vertical pole. The groma allowed them to draw perfect straight lines and right angles over vast distances. An engineer using a groma could accurately aim it at a distant point marked by a torch or signal pole. Then, using plumb lines and sight lines, he would draw a straight line that served as a guide for the construction crews. This minimized errors and avoided unnecessary curves. The straightness of the road was not just an aesthetic choice, it was a functional necessity. The straighter the road, the shorter the distance, and the faster the legions could reach their destination. Reducing the distance by 10–20% across the empire resulted in enormous savings in time and resources. Of course, the Romans were not fanatics of absolute straightness. They made adjustments for the terrain. If a mountain was too high, they preferred to go around it rather than dig a tunnel through it. However, on relatively flat terrain, the road was almost always perfectly straight, and curves were only made to bypass serious natural obstacles, such as deep gorges or large swamps. In the process of laying out the route, engineers also actively used a spirit level, the prototype of the modern level. It allowed them to control the horizontality of the roadbed and ensure the necessary slope for water drainage. This was important to prevent puddles from forming and damaging the road. The use of these tools and rigorous surveying calculations allowed Roman engineers to plan the entire route in advance, including bridges, embankments, and cuttings. This eliminated the need for sudden changes during construction and allowed workers to move forward at a high, predictable speed. The surveying skills of Rome were so advanced that they could build straight roads through dense forests and sparsely populated areas. This was an important factor in integrating new territories into the imperial system. The Romans also understood that a road was useless if it was interrupted by a river, ravine, or marshy lowland. That is why bridges and aqueducts, which were often built in parallel, became some of the most impressive engineering achievements of the empire. These structures did not simply connect the banks, they demonstrated the skill of Roman engineers and symbolized Rome's ability to overcome any obstacle. Troops, trade caravans, and even carts carrying cargo could cross these bridges without stopping traffic. Aqueducts and bridges were visible proof of the power and organization of the Roman Empire. Each structure was carefully designed to last for decades and withstand hundreds of tons of weight. Bridge construction was the most difficult and expensive stage of road construction, requiring skill and a large amount of resources. The Romans did not shy away from this work, even if the site was particularly difficult. They built bridges out of stone and concrete, using the arch principle, which allowed the load to be distributed evenly throughout the structure. This principle ensured incredible strength and durability, allowing the bridges to stand for centuries. Many arch bridges built in Rome and the provinces have survived to this day, confirming the skill of the engineers. They knew that the strength of the supports was the key to the long service life of the entire road. Roman concrete, known as opus cementicum, was a unique material that significantly surpassed modern analogs in terms of durability. The secret of its strength lay in the use of volcanic ash, which made the concrete water-resistant. This material could harden even underwater, making it ideal for the construction of bridge supports and aqueducts. Thanks to this concrete, bridges did not collapse after heavy rains, floods, and centuries of use. Roman concrete allowed for the creation of structures of any shape, which gave engineers enormous freedom in design. Over time, the technology of construction using this material became the standard for many generations of builders. To build bridges, temporary wooden caissons were first constructed and lowered into the riverbed. Water was pumped out of these caissons, creating a dry space for masons to work. Stone or concrete supports were then erected to serve as the foundation for the future arch. Wooden scaffolding was installed on the supports, on which stone arches were laid out, carefully fitting each block. This process required extreme precision so that the arch could withstand the weight and pressure. When the stone structures were completed, the wooden scaffolding and caissons were carefully dismantled to check the stability of the arch. The most critical moment in bridge construction was the removal of the supporting structures, which required precise calculation and skill. Even a small mistake could lead to the destruction of the entire structure. The Romans were not afraid to build multi-tiered bridges, creating complex engineering structures across rivers and ravines. Multi-level bridges allowed for the combination of transport and water communications, as well as facilitating movement at different heights. The construction of such structures was considered the highest task for Roman engineers and required the organization of hundreds of workers. Each stage was monitored to ensure the durability and safety of the structure. Aqueducts, although used to deliver water, were often built along roads and using the same technologies as bridges. They required precise slope calculations so that water could flow for tens of kilometers without the aid of pumps. Some aqueducts, such as the Pont du Gard in France, also served as bridges, crossing rivers and valleys. They were not only engineering structures, but also aesthetic masterpieces. Roman engineers took into account all elevation differences, water flow velocity, and material strength to ensure the reliability of the structure. These structures demonstrated the fusion of practicality and beauty, characteristic of Roman engineering. Roman engineers were true masters of hydraulic engineering. They knew how to build bridges over large rivers and construct embankments, dams, and canals to keep roads passable even in swampy areas. For example, when building the Appian Way through the Pontine Marshes, they had to create a drainage system to stabilize the ground and ensure safe travel. Engineers took into account all natural factors, from groundwater levels to soil types. Thanks to this, the roads remained strong and did not deteriorate over time. Each such structure was carefully calculated to serve many generations. The entire system was based on a clear division of labor. Each construction crew or cohort was responsible for a specific stage of the work. Some were engaged in clearing the area and cutting down trees, others in digging trenches, others in quarrying and transporting stone, and still others in laying the layers. This specialization allowed workers to quickly master their tasks and work at maximum speed. As already mentioned, the legions were the main workforce, but contractors were hired for civilian projects and large-scale work. These contractors usually had a large number of hired workers and slaves at their disposal. The state exercised strict control over quality and deadlines, which encouraged them to work quickly. The working day was long, beginning at dawn and ending at dusk. Under military discipline, there was no room for idleness or laziness. Work efficiency was increased through constant control and motivation. For legionnaires, this meant honor and promotion, and for hired workers, it meant timely payment. The tools used by the Romans were also optimized for speed. These were sturdy shovels, pickaxes, hammers, and wheelbarrows made of iron and standardized. The availability of a large number of identical tools allowed work to be carried out on a wide front simultaneously. The logistics of delivering materials were thought out in detail. Quarries were often located directly at the construction site to minimize transportation costs. Thousands of carts and mules, as well as river and sea transport, were used to deliver stone and sand. Roman roads were, in essence, a self-financing project. Taxes and duties collected from merchants who used these roads were partially used for their repair and maintenance. This created a sustainable system that did not depend on one-time subsidies. The organization of labor was so efficient that, according to historians' estimates, construction crews could build up to 1 to 2 kilometers of road per day on relatively flat terrain. This speed was achieved through a combination of military management and a conveyor belt system. Raiding, or raids, were the basis of Apache military activity. They used their mobility and knowledge of the terrain to suddenly attack their enemies and quickly disappear into the desert or mountains. For them, each attack was planned as a strategic operation, taking into account the features of the terrain, hidden trails, and water sources. The Apaches could raid over long distances and return with loot, remaining virtually untouchable. Their success depended on their ability to combine reconnaissance, stealth, and speed. Raids were their primary means of influencing their enemies and defending their territory. For the Romans, everything was different. Road construction in their army had its own anatomy of a raid, but it served a single purpose: the speed of troop movement and the safety of transport. It was not just a construction process, but a whole system of operations that was carried out like a well-coordinated military maneuver. Each stage of the work was planned in advance, taking into account resources, terrain, and possible obstacles. Road construction in Rome combined engineering skill, labor organization, and the strict discipline of the legions. It allowed armies to move quickly and efficiently throughout the empire, minimizing the risk of delays and damage to the road. It all began with the reconnaissance and planning stage. Military engineers and surveyors carefully studied the terrain, measured heights and distances, and determined the most direct and safest route. They used tools such as compasses and measuring rods to accurately record the terrain and plot it on maps. At this stage, detailed plans for the future road were created, taking into account all bridges, embankments, and drainage systems. Every decision was made with many years of operation in mind. Maps and diagrams were an essential part of the preparation process to ensure that the work proceeded quickly and without errors. This was followed by the clearing and marking stage. Thousands of workers, soldiers, and legionnaires cut down forests, removed stones, and leveled the ground. Using stakes, ropes, and marks on the surface, the width of the road and its center line were precisely determined. This stage required a huge number of people and coordinated work because the accuracy of the marking determined the entire subsequent laying of the layers. The legions moved as a single mechanism. Some cleared the site, others leveled it, and still others began laying the foundation. The mobility of the troops allowed them to work on several sections of the road at the same time. Next came the earthwork stage, which was critical to the durability of the road. Workers dug trenches for the foundation, removed large irregularities, and created embankments in low-lying or swampy areas. The excavated soil was used for side embankments, which served as a natural barrier and improved drainage. Sometimes it was necessary to reinforce the embankments with stone or wooden structures to prevent the soil from crumbling. All work was carried out strictly according to plan and under the supervision of engineers. This stage ensured the stability and strength of the future roadbed. After that, the layer-laying stage began, which resembled conveyor belt work. One group delivered large stones for the first layer, another fastened them with mortar, a third laid crushed stone, and a fourth prepared the next layer. The work was carried out on a broad front, with each team following the previous one, performing its part of the task. This organization saved time and increased the efficiency of construction. Even with large distances between the groups, the road was built simultaneously on many sections. Each operation was strictly coordinated to ensure that the layers were laid evenly and the strength of the roadbed was maintained. A critical stage was the construction of engineering structures such as bridges and aqueducts. They were built simultaneously with the roadbed so that the overall process would not slow down. This work was the slowest and required maximum precision because any mistake could destroy the entire road. Bridges were built of stone and concrete using an arch design, and aqueducts were carefully leveled with a precise slope. Their construction began in advance so that they would be ready by the time the main road reached them. Such structures ensured not only passability, but also the durability of the road for many decades. The final stage consisted of laying the finishing surface of stone slabs and installing curbs. This work required maximum accuracy and skill, as a flat surface was key for the movement of carts and troops. The stones were selected and fitted so that they fit tightly, preventing water from penetrating the layers. The curbs secured the road and protected it from spreading. After this work was completed, the road was considered ready for use, and traffic could begin immediately. Each stage was carefully checked to ensure the durability of the structure. After construction was completed, milestones and post stations were installed to record mileage and provide communication between cities. The road was officially put into operation, and troops, trade caravans, and couriers began to travel on it. Repair and maintenance work was carried out regularly by special road services. The roads remained strong thanks to constant monitoring, cleaning, and reinforcement of the pavement. This organization allowed Rome to maintain its road network in good condition for centuries. On paper, the American cavalry had an overwhelming advantage over the Apaches. The Romans had an overwhelming advantage over everyone, and their roads were the key to this. The roads were the lifeblood not only of the army, but of the entire imperial communication system. In this context, Roman roads gave the empire a speed that no other civilization could match. A key tool in this communication was the cursus publicus, or state mail system. It was a highly organized network of stations and couriers that allowed official orders, government letters, and important news to be delivered at a speed that was incredible for the ancient world. Along all major roads at intervals of approximately $15–25 kilometers, there were special stations called mutationes, or horse-changing stations. Here, couriers could quickly replace tired animals with fresh ones without wasting time on rest. Every 40–50 kilometers, there were larger stations, mansiones, which served as places to stay and rest. These were a kind of hotel with provisions, where you could get fresh food, repair your carriage, and spend the night. Thanks to this system, official couriers traveling with imperial orders could cover up to 80 kilometers a day, which was a phenomenal speed. In urgent cases using a relay system, it was possible to reach speeds of up to 250 kilometers per day. This speed was vital for governing a vast empire. The quality of the road was directly related to the speed of communication. The smooth stone surface allowed horses and carts to move quickly without fear of getting stuck in the mud or breaking a wheel. The straightness of the route, as we have already mentioned, reduced travel time. Civilians and merchants, although not entitled to use the cursus publicus, also benefited from the quality of the roads. The rapid delivery of goods and raw materials stimulated trade, which in turn strengthened the empire's economy. Roman roads were, in essence, the telecommunications system of their time. They allowed the emperor in Rome to make decisions based on the most up-to-date information and to quickly convey his orders to the most remote corners of the empire. Relying on their superior logistics, which was ensured by their roads. For them, roads were not just transport arteries. They were a strategic tool that allowed them to control territories, move troops quickly, and maintain economic dominance. These roads were used to deliver food, weapons, and finances necessary to support the army and the functioning of the empire. They ensured the stability of power and the ability to govern distant provinces without the risk of delays and disruptions. Roads connected cities and forts, making the empire cohesive and manageable. Without such a logistical system, it would be difficult to imagine the effectiveness of the Roman army and administrative apparatus. The construction and maintenance of roads was part of a well-thought-out economic strategy. High-quality roads reduced the cost of transporting goods, shortened delivery times, and allowed for a quicker response to any crisis situations. This directly affected food prices, their availability to the population, and the profits of merchants. The better the road, the faster grain, wine, or olive oil could be delivered to large cities, maintaining their supply and stability. Reliable infrastructure contributed to the development of trade and the growth of tax revenues, which strengthened the economy of the entire empire. Each road built was both an economic and strategic resource. The Roman government actively used roads to collect taxes and duties. Improved infrastructure allowed tax inspectors to quickly reach the provinces and control the collection of funds. This prevented delays and losses, making the system more efficient. The funds collected from merchants and residents reached the treasury faster, which supported the stability of the state's finances. Roads provided a direct link between the provinces and the center of the empire, making governance more transparent and controllable. Thus, roads were not just a means of transportation, but also an instrument of economic discipline. The standardization and directness of the roads simplified the control of trade and population movement. At posts located along the roads, passing caravans were recorded, fees were collected, and documents were checked. This allowed the state to receive additional income and prevented the illegal movement of goods. Such measures contributed to security, protection against smuggling, and simplified economic management. Roads became a link between the provinces and the center, creating a system in which financial flows were easily tracked. Thanks to this, Rome was able to effectively control vast territories without an excessive number of officials. Roads contributed to the specialization of regions and the development of local production. If it was profitable to produce wine, olive oil, or fabrics in a particular province, the presence of a road made their transportation economically viable. This stimulated production, increased provincial revenues, and raised the overall level of trade. Roads connected local markets with large cities, making the transport of goods fast and safe. As a result, regions developed and the empire's economy strengthened. Each road became a stimulus for production and exchange, supporting long-term prosperity. We conclude our study of the phenomenal speed and durability of the Roman road network. The secret of Rome lay not in any single unique technology, but in a brilliant combination of several factors: strict standardization of construction, military management involving legions, sophisticated geodesy for laying straight routes, and investment in infrastructure as a tool of power and economic control. These roads were built to last for centuries because they were considered the foundation of the empire itself, not a temporary fix. Rome's experience shows that when will, resources, and clear planning come together, it is possible to achieve results that seem incredible even today. They built a global road network faster than we can repair a single highway because they saw it not as a problem, but as the only sure way to maintain their dominance. Which of these components of Roman success, military management, standardization, or engineering technology, do you find most ingenious and why? Suggest topics for future videos that you would like to see on our channel in the comments, and don't forget to subscribe so you don't miss new episodes.